Hello and welcome to another tutorial of SystemVerilog in 5 minutes. Today we'll be talking about class polymorphism. This is a simple class C number. It has a rand variable I and a print function. This is an extension class ECNumberOdd. It extends from C number and therefore inherits all its contents. On top of that, it has an extra constraint which will make the variable I to be an odd number. This is another extension ECNumberEven, which has a constraint that makes I an even number. Now we can use these classes. Here we create these three pointers or handles. We can then instantiate the classes. The CN object is used to get a random number. The CNO object is used to get a random odd number. And the CNE object is used to get a random even number. These three lines of code can be refactored. We can create a task to perform the execution. The problem is how to create one task to operate on three different classes. Actually, because of inheritance, these three classes can be considered as a same type. They are all CNumber class. Thus, the task here can contain an argument of CNumber. You can call the task passing in the object, and the argument will randomize the object according to the constraint the object carries. Let's focus on the task here. Basically, the task behaves differently every time it is called, depending on the object that is passed in. This multiple behavior is what we call polymorphism. It is achieved by combining the behavior of a class pointer and inheritance. Now let's take a look at another form of inheritance. This is the same class as before. This is a new extension ECNumberHex where we override the function print. It will print the number in a hexadecimal format as compared to the original decimal format. Similarly, we create two handles here, and then we instantiate them, and then we call the randomize and print function. The CN pointer has only one print function. It will always call the CNumber print function, and therefore will print the number in a decimal format. However, the CNH pointer has two print functions, one from the CNumber class and another from the ECNumberHex class. But as an ECNumberHex pointer, it will call the print function from the extension class, and will print the number in a hexadecimal format. Now let's try to create a task. When you call the task, an argument is created. First, argument arc points to the CN object. Basically, arc and CN are the same kind of pointer, so arc will call the print from the CNumber class. Now we call the task with CNH object. We know the CNH object has two print functions, but the argument pointer is a CNumber pointer. The argument does not know about the overridden function. Argument.print will call the base class print. Now this is undesirable. It defeats the purpose of polymorphism. We want the task to be able to call an overridden function. We can achieve this by adding the keyword virtual to the methods. Let's take a look at how a virtual method works. Calling run with CN object, the behavior is the same as before, but when calling run with CNH object, even though the argument is a CNumber class, when you call the print function, it will look for an overridden version from the object. In this case, argument.print will refer to the overridden print in the extended object, and thus will print the number in a hexadecimal format. Now let's look at some restriction. This is a simple CNumber class. This is an extension ECNumber. We can create and instantiate the classes. What we've learned so far is that we can create a pointer using the base class CNumber. The pointer can point to both the objects. However, the pointer cannot access the constraint CST and the function print from the extended ECNumber object, simply because it is unaware of them. As a general recommendation, a base class should have all the necessary methods, especially those accessible by users. On the other hand, if you create a pointer using the extended class ECNumber, the pointer will have information on the constraint CST and the function print, but it cannot point to a base object, simply because the object does not contain those members. This violates type compatibility in assignment. A more interesting case is where you have different kind of pointers. First, the base pointer points to an extended object, and then we want the extended pointer to point to what the base pointer is pointing at. Logically, this is reasonable, but syntactically, it's not allowed. However, if you are sure the class assignment is compatible, you can use cast to perform the assignment. In summary, a class polymorphism behavior is a resulting behavior of a class pointer and class inheritance. Next, we'll be talking about coverage.